Let's take a look at analyzing arguments with truth tables, section 3.6, and the problems begin on page 130. And in the first group it says each argument is either valid by one of the forms of valid arguments discussed in this section, or is a fallacy by one of the forms of invalid arguments discussed. And it says to see the summary boxes. They're talking about the summary boxes back on page 128. Decide whether the argument is valid or a fallacy and give the form that applies. So let's take a look at number 2. Let me read through the problem. If you use binoculars, then you get a glimpse of the space shuttle. If you get a glimpse of the space shuttle, then you'll be amazed. If you use binoculars, then you'll be amazed. So we have a series of if-thens. If P, then Q, then if Q, then R, and finally the conclusion, therefore, if P, then R. So that is valid by reasoning by transitivity. So valid and it's by reasoning by transitivity. Series of if-then statements. Okay, let's look at number 4. It says if Andrew Noble sells his quota, he'll get a bonus. Andrew Noble sells his quota, therefore he gets a bonus. So we have an if-then. So we have if P, then Q, P, therefore Q. And that one is also valid by modus ponens. Sometimes this is called direct reasoning. Okay, our text calls it modus ponens, using the Latin name for it. Okay, in number 6, if she buys another pair of shoes, her closet will overflow. Her closet will overflow, therefore she buys another pair of shoes. So we have if P, then Q, Q, therefore P. This one is a fallacy because it's what we call fallacy of the converse. So it's fallacy of the converse. Or you might say it's invalid by fallacy of the converse. Might sound a little bit better. Okay, number 8. If Nelson Dida plays, the opponent gets shut down or shut out. The opponent does not get shut out, therefore Nelson Dida does not play. And so we have if P, then Q, not Q, therefore not P. So this one is valid. And what we notice is this is the contrapositive of what we call direct reasoning. So it's called modus tollens. So that one is valid. Let's look at number 10. If I have seen farther than others, it is because I stood on the shoulders of giants. And I have not seen farther than others, therefore I have not stood on the shoulders of giants. And this one is if P, then Q, not P, therefore not Q. So this is fallacy of the inverse. So again, you can say fallacy or invalid, and it's the fallacy of the inverse. Okay, and we have one last one where we're recognizing the pattern. Mia kicks or Drew passes. Drew does not pass, therefore Mia kicks. That's valid by by disjunctive reasoning. We have P or Q, not Q, therefore P. So disjunctive reasoning makes it valid. Okay, now I want to do just a couple that we would solve with a truth table. In this next group it says use a truth table to determine whether the argument is valid or invalid. So let's look at number 16. The argument is P or not Q, P, therefore not Q. Okay, and this is a symbol for therefore. You may see in some cases. Okay, so let's test that. Alright, we need a column for P, a column for Q, and I'm making this way too big because we only need 4 rows. Okay, and we need a column for not Q. We need a column for P or not Q. So remember how we do this. We form the conjunction of the premises. Those two are our premises. So I need that in the next column. P and P or not Q. Okay, and then our final column needs to be the premises implying the conclusion. So P and P or not Q. If that, then not Q. So that's our final column. And for it to be valid, we have to have all truths when we get way over there. Okay, so here's our normal setup. First 2 truths, 2 falses under P, and then alternating true, false under Q. Negating Q, we'll get false, true, true. P or not Q, we have true or false would be true, true or true is true, false or false would be false, and then false or true would be true. Now we want to join that column with an and I'm going to highlight the 2 to keep me straight here. True and true would be true, true and true would be true, false and false would be false, false and true would be false. Okay, so now we're working on, and let me highlight with a different color. Let's use blue. I want this column to imply not Q. And again, I'm highlighting just to keep myself straight. If true, then false would be false. If true, then true. If false, then false. If false, then true. So because of this false, it is invalid. The argument would be invalid. Okay. All right. Okay. Let's see. Okay, I think I'll stop with that, and let's go ahead and take a look at determining whether an argument is valid or invalid based on what is given. And what they do is they give us a problem, and we have to figure out whether it's valid or not based on one of our methods that we have come up with. So we either can do an Euler diagram, we can recognize the pattern, or we can use a truth table. So let's take a look at number 30. Okay, it says that if Hurricane Gustav hit that grove of trees, then the trees are devastated. So I'm going to use an H. If H, then devastated. Okay. People plant trees when disasters strike, and the trees are not devastated. So P and not D. Therefore, if people plant trees when disasters strike, therefore, if people plant trees when disasters strike, then Hurricane Gustav did not hit that grove of trees. Okay, so, oh my goodness, we have all kinds of things to work on here. Let's go through and double check. Okay, if Hurricane Gustav hit that grove of trees, okay, if it hit, then the trees are devastated, so that's the D. People plant trees, that's P, when disasters strike and the trees are not devastated. Therefore, if people plant trees when disasters strike, then Hurricane Gustav did not hit. So if P, then not H. Okay. Okay, so let's take a look. Is there an easy way we can do this, or are we stuck with using a truth table? Alright, I don't see any of our argument patterns that will actually help us. An or statement can be substituted for an if-then, but I don't believe that's going to help us. So we're going to need 8 because we have 3. Okay, and I'm going to do D. I like to do mine alphabetically. And P. Alright, we're going to need a not D and a not H column. And let's see, so we need if H, then D. We need P and not D column. We need the conjunction of those to form the premise. So if H, then D. And you can see now why I didn't do another. Okay, and our last one would be P, then not H. Actually, that's not the, and this is the whole thing. This is that column implies that column. So